Okay, so far we've been talking about quadratic equations, right? So we went through the definition of a quadratic equation, also called a second degree polynomial, right? We'll talk about higher degree polynomials soon as well. We talked about how to solve quadratic equations by factoring, right? We did an example where we pulled out the greatest common factor, right? So we saw a special case, basically, of factoring by pulling out the greatest common factor, right? And we did an active engagement assignment on that as well, right? Which hopefully I will have back to you. Well, I'll have it graded this weekend, so I'll give it back to you on Tuesday next week. Okay, so let's talk about factoring a little bit more, all right? So like I said, we've only done like a special case of factoring really where C is equal to 0, right? So then what happens if C is not equal to 0, right? Well, if C is not equal to 0, then all you can really do is, well, you got to kind of factor it the hard way. Okay. So I'm going to go ahead and subtract 4 on both sides of the equation, right? And the reason that I'm going to do that is because I want to put this thing into its general form, its standard form, right? So I'm going to take the left-hand side here, right? Subtract 4. I'm going to take the right-hand side here and subtract 4. So I'm going to be left with 2x squared plus 7x minus 4 is equal to 0. And then now that's in the nice form, the standard form that we like for quadratic equations, okay? Now comes the part where I have to factor this thing, okay? And it's going to factor as two binomials, right? So there's going to be some number here times x plus some other number here, and then some number here times x plus some number here. And our goal is to find out what those four numbers that go in those four boxes are, right? Okay. And so, like I said, I looked online for like different strategies for factoring, and they all boil down to eventually doing a trial and error basis. So we're just going to go with trial and error. Now, the good thing is we know some stuff about this. This first box right here times this first box right here. If I multiply these together, they have to be equal to the leading coefficient. Yeah, they have to be equal to 2. Okay, so that leaves us with no choices really on what we can choose there, right? Get rid of this, get rid of this, right? One of these has to be 2, and the other one has to be 1, right? 2 times 1 is 2, right? So prime number, okay? So good, we have that at least, okay? So now I just have 2 boxes to deal with, right? And the good thing is that this box times this box has to be equal to -4, right? Okay. So that limits my options for those boxes as well, right? So we have to think, well, how can I write -4 as a product of things, right? Well, I could have a -2 times a +2, right? I could have a -1 times a +4, right? I could have a -4 times a +1, right? And I think that's all the options, right? Yeah. Fair enough. So we got to try those options in here. Okay. And so if I just like plug in, let's say, oh, -4 is -2 times 2, right? Then I could try and maybe since I'm guessing here, I'll put this in red, -2 over here, +2 over here, right? Let's try those out and see what happens when I FOIL it back out, right? I get 2x times 1x is 2x squared, which we knew was going to happen anyway. That's why we chose 2 and 1 there, right? We do have -2 times +2 is equal to -4. That's great, right? But what about this middle number right here, right? So if I take 2x times my 2, I get 4x. If I take -2 times 1x, I get -2x. So if I add those together, I get a 2x, not a 7x. So that didn't work, right? Yeah, it didn't work. So that was not correct then. Okay. So what can we do? Well, let's try another option. Okay. So how about we try -1 and +4, right? Or I guess, well, really, I haven't exhausted that possibility yet, right? Because I could have switched the order. It could have been 2 over here and then -2 over there, right? So I'll put my plus sign back over here. So what if I instead did this as +2 and this as -2, right? Okay, so if I try that out now, well, I still get my 2x squared, I still get my -4, but now let's see. I get 2x times -2 is -4x. I get 2 times 1x is 2x. I get -2x, right? Which is still not 7x. Yeah, so that still didn't work, okay? All right, so I'll get rid of that then. Now we've truly exhausted that possibility, right? Let's try -1 and +4, right? See if that works. So I'll put a -1 over here. I'll put a positive 4 over here. Let's see what happens. We get 2x times 1x is 2x squared, right? Which we already knew was going to happen. Negative 1 times 4 is negative 4, which we already knew was going to happen, right? But let's see if we can get this term right here. So 2x times 4 is 8x. Negative 1 times 1x, that's negative x. So 8x minus 1x is indeed 7x. We did it, right? Fair enough. So this is the correct formulation here, right? This is how we want to write negative 4. Yeah. So now we have that my quadratic equation factors as 2x, and I'll write this as minus 1 times x plus 4. Okay. Yeah. So we factored it now. And that's essentially what you're doing no matter what strategy you're doing with the trial and error basis. Okay. Yeah. So any questions on that? Any questions on that? All right. Well, now that I've factored it, remember we're trying to solve this quadratic equation, right? So now we use the zero product rule, right? Zero product rule, which says that 2x minus 1 has to be equal to 0, or x plus 4 is equal to 0. Just in case you forgot what the zero product rule says, it says anytime we have some quantity times some other quantity is equal to 0, well, the only way we can multiply two things to get 0 is if one of those two things was 0 to begin with, right? So either 2x minus 1 had to be equal to 0 or x plus 4 had to be equal to 0, right? That's the only way we could multiply those together and get 0, right? Fair enough. All right, so then now we can solve these, right? So I have 2x minus 1 is equal to 0. So I'm going to take my left-hand side here and add 1, which means I got to take my right-hand side and add 1 as well, right? Do the same thing to both sides. So here I'm going to be left with a 2x on the left-hand side. On the right-hand side, I'm going to be left with a 1. Now I'm going to divide both sides by 2. So 2x over 2 is equal to 1 over 2. So I get that x is equal to 1/2. Okay, so that's my first solution there. Yeah. This one's a little bit easier, right? We have x plus 4. We're going to subtract 4. We have 0. We're going to subtract 4. And now I'm going to be left with x is equal to negative 4. Okay. So my solution set, right? If I go from smallest to largest, that would be negative 4, comma 1/2. Okay. On the test, I don't care which one you put first, as long as you have them both there, right? Okay. So any questions on that? Any questions on that at all? All right. All right, so in general, that's what we'll be doing when we factor quadratic equations. We have to write it as a product of binomials like that. We have to do trial and error. However, I do want to go through two special cases of factoring now. Okay, so special cases of factoring. Okay, so the first way, right, we're going to call this rule, and I don't think this is the way that, yeah, I think that this is the way that most textbooks call it, square of a sum or difference. Okay, so basically, here's the setup here. And it makes more sense when you see it in reverse. So I'm going to do it in reverse. Basically, well, what is the square of a sum or difference? Well, we're going to have a binomial like this, ax plus b, that we're squaring. Okay? Yeah. And when we do that, when we square this out, when we FOIL it out, right? Let's see what we get. So ax plus b times ax plus b, right? So then ax times ax would be a squared x squared, right? And then we get an ax times a b, right, which is just a abx. But then we get another abx, so this is plus 2abx, and then plus b squared, right? Fair enough. Yeah, no problem. I am writing extraordinarily small today. There we go. There we go. Fair enough. So it's called the square of a sum because we have a sum here and we're squaring it, right? Yeah. There's a difference formula also. So ax minus b, we square that, right? This is the same thing as ax minus b times ax minus b, right? And so we're going to get an a squared x squared minus a 2ab, x plus AB squared. Okay. Oh, now that I've zoomed in, I'm still writing small. Hold on. Let me make that bigger here. A squared x squared minus 2abx and then plus b squared. There we go. All right. So basically, if you see a quadratic equation, right, where the left-hand side looks like this, right, which it looks pretty messy, really, right? But if you did notice it had this form, then you could factor it in this way, right? It's just ax plus b quantity squared, right? Same thing with this one. If you notice that your left-hand side looked like this, then you could factor it in this way. Okay, so let me show you a quick example of how that might occur in real life, right? Maybe you have x squared minus a 6x plus a 9 is equal to 0. Okay, something like that. Okay, so I'm going to rewrite this so that it looks a little bit more like this. Okay, this is the same thing as 1 squared times x squared, right? Because 1 squared is just 1, right? Minus, well, 6 is really just the same thing as 2 times 1 times 3, right? So I'm just factoring this. And then 9 is the same thing as 3 squared. Okay. Fair enough. So now that I have that, well, it's pretty clear that my a is equal to 1, right? Yeah, this a squared is 1 squared, so a has to be 1 there, right? And that my b is 3, right? So then we're going to have that, oh, I said 3. Yeah, that's right. Okay. B is equal to 3, because 3 squared is equal to 9. Okay, we're good. So then now, right, since it came in this form, right, where we had an a squared x squared minus 2abx plus b squared, right, that means it factors like this. Okay. So it's just going to be ax minus b, basically. So this factors as, well, my a is just 1. How did it come out to be a heart? All right. So it's 1x minus my b is 3, quantity squared equals 0, right? So that just factors as x minus 3, quantity squared equals 0, okay? Which I can solve very easily. That just means that x equals 3, right? Fair enough. So we only get one solution there. Yeah, we only get one solution. Okay, this is called a repeated solution. Repeated solution or repeated root. Yeah, why is it called repeated? It's because if we actually write out the definition of x minus 3 squared, we know that that's x minus 3 times x minus 3 is equal to 0. So by the zero factor property, we get that either x minus 3 is equal to 0 or x minus 3 is equal to 0, right? So we get x equals 3 twice, basically. Yeah. And so that's why it's called a repeated solution or a repeated root. Okay. Any questions on that? Repeated? Yeah. Okay. So that's how we might use the square of a sum or difference. Okay. And honestly, like, most of the time, those are kind of hard to see, right? Basically, if you've done thousands of these problems, you might recognize that this thing can factor as a perfect square like this. Yeah. Okay. But this next one, is a lot more easy to notice. Okay. Okay. So this one, instead of being a square of a sum, right, or square of a difference, this one is called the difference of squares. Okay. And so basically, here's what it looks like. You have, let's say, a quadratic equation that looks like this. Do I want to say? Yeah, I'll call it a and b still. Okay. So I have a squared x squared minus b squared. Yeah. So you basically have something squared minus something squared, which is why it's called a difference of squares. Okay. Fair enough. Now, this always factors as ax minus b times ax plus b. Yeah, always. And you can FOIL it out and you can see that your middle term is going to cancel basically, right? We have ax times ax is a squared x squared, right? Ax times b is plus abx, but then we have this minus b times ax, so we get minus abx, so they're going to cancel off. And then we have minus b times b is b squared. Okay, fair enough. So as a quick example of that, right? Let's say we had, I don't know, 4x squared minus 7 is equal to 0. Okay. And you know what? Let's make it a perfect square. Let's go ahead and make it a perfect square there. 4x squared minus 25 is equal to 0. Okay. All right, so that's clearly a perfect square and a perfect square there, right? So my a, well, remember a squared is equal to 4, so that means my a has to be 2, right? My b, well, remember that b squared has to be 25. Positive 25, not negative 25, right? This minus sign is built into the formula there, right? Yeah, that's why it's called a difference of squares. So this is a positive 25 right here that we're subtracting. My b is going to be 5 then, right? If b squared is 25. So now this thing is going to factor as 2x minus 5 times 2x plus 5. Okay, fair enough. So that's kind of nice. Yeah, a lot nicer than the first one anyway, right? Yeah. Now that I have that, I can say by zero product rule, right? I have that 2x minus 5 is equal to 0, or 2x plus 5 is equal to 0, right? And then now I can solve this thing, right? So I get 2x minus 5 plus 5 is equal to 0 plus 5. So I get 2x is equal to 5. Now I'm going to divide by 2 on both sides. And I get that my x is equal to 5 divided by 2. Okay. Over here, I'll do all the same steps. 2x plus 5, but now I got to subtract 5. Right? So I get 2x is equal to negative 5. Right? Now I'm going to divide by 2 on both sides. Right? So I'm going to get that x is equal to negative 5 halves. Okay. And so your solution set is, if I go from smallest to largest, it's negative 5 halves, 5 halves. Okay. Other ways that MyLab Math might have you express your final answer, right? They might have x is equal to, and you have to fill in the blank over here, right? And they might write a plus or minus 5 halves, like that, right? Fair enough. Plus or minus, because it's either positive 5 halves or it's negative 5 halves. Both of those are solutions, right? Okay. Okay. All right. So that's all I really want to say about factoring for right now. Any questions on that? Any questions at all on that? All right. I'm going to scroll up a little bit then. So now let's talk about solving quadratic equations. Still talking about that. Quadratic equations. But now we're going to use something called the square root property. Square root property. Okay. And I think probably on our very first day of class, I said something to this effect, right? Let's say we had x squared equals 4, right? We're trying to find the solutions to that, right? So then we take square roots on both sides, right? And we get the square root of x squared is equal to the square root of 4, right? Yeah. Now remember that square roots only return positive values. So if I take the square root of x squared, well, if it's positive, if x is positive, then the square root of x squared would just be equal to x. Yeah. But remember that x is a real variable. It's allowed to be negative or positive, right? So in the event that x is a negative number, well, we got to take the absolute value of it. So the square root of x squared is not just x, right? The square root of x squared is the absolute value of x. And that works whether x is positive, x is 0, or x is negative, right? So whenever you're simplifying square root of x squared, that's the absolute value of x. Okay. And so we get that the absolute value of x is equal to 2. And so then x is equal to either positive 2 or negative 2. That's the only two things that satisfy that equation. And that's why we get this plus or minus 2 thing. That's where it comes from. Okay. I just wanted to remind you of that because we're going to be basically doing the same thing with the square root property here. Okay. Yeah. So what the square root property says is the following. I'll try to phrase it pretty formally here. All right. So this is a little aside here, a reminder. Okay. Now, If U is an algebraic expression, right? Just some quantity is an algebraic expression. And D is a non-zero number. Okay, and we'll talk about why it has to be non-zero in just a second, right? Then U squared equals D, right? Has exactly two solutions. Right? And those solutions are that U is equal to the positive square root of D, or U is equal to the negative square root of D, right? Because we took the square root on both sides, we got the plus or minus, right? Okay, fair enough. All right, so any questions on that so far? Any questions on that? All right. Well, let's talk about why they say, well, if D is non-zero, that this happens, right? Well, what happens if D is equal to zero? So I'll write a little note over here. What? So if D equals zero, then U squared equals zero is what we would have, right? Which has only one solution, which has only U equals zero as a solution. And I'll call it a repeated solution now that we know what that is, right? Or a repeated root. Okay. Fair enough. And so that's why they make that stipulation there that this works if D is not zero. You get two distinct solutions. Okay. So I'll pause here. Any questions at all? Maybe I'll get off my feet here too. Kind of want the nice chair. Let's take the nice chair. It's even still got a tag on it. All right. Any questions? Yeah, we're all okay with that. Flying through this. That's good. Okay. So let's do an example. So as an example here, right, for part A, let's say we have 3x squared minus 15 is equal to 0. Same instructions as for the previous example, right? Find all solutions to the quadratic equation. Yeah. Okay. So there's a couple ways you might start here. I noticed that 3 and 15 are both divisible by 3. So I'm just going to divide both sides by 3 to make it smaller numbers. Okay. Yeah. So then I'm going to have 3x squared minus 15 divided by 3 is equal to 0 divided by 3. Right? Okay. Now dividing by 3, that distributes. So this is the same thing as 3x squared over 3 minus 15 over 3 is equal to 0. Right? And then, of course, my 3's cancel off here, so I'm just left with x squared minus 15 over 3 is 5, and that's equal to 0, right? Now, just a quick note here. This is really a difference of squares, okay? And you know what? Maybe I'll put this in purple here so that we know that this is not part of the solution that I'm trying to do here, right? But this is really a difference of squares. This is the same thing as x squared minus the square root of 5 squared is equal to 0. So we could solve it using our difference of squares formula if we wanted to. This thing just factors as x minus the square root of 5 times x plus the square root of 5 equals 0. So we would get that x equals square root of 5 and x equals negative square root of 5 as our solutions, right? Yeah, so we could have done it that way, okay? But I'm trying to use the square root property instead, okay? Yeah. Yeah. All right, so let's use the square root property instead here. So I have x squared minus 5 is equal to 0. In order to use the square root property, I have to have my squared quantity is on one side of the equation, and everything else is on the other side. Yeah, fair enough. So I need to add 5 to both sides of the equation here. So I have x squared minus 5 plus 5 is equal to 0 plus 5. So then I get that x squared is equal to 5. Okay, so now I'm ready to use my square root property. I have a quantity squared is equal to a non-zero value, right? Yeah. So then there are two solutions, right? So you can say by square root property, SRP. Yeah, by square root property. X is equal to square root of 5 or x is equal to negative square root of 5. Those are my two solutions. Okay. So my solution set is negative square root of 5, positive square root of 5. All right. So that wasn't so bad, right? Yes. So I'm showing you lots of different strategies for doing it because some ways are faster than other ways depending on the problem that's given to you. Yeah. So ultimately, right, when you're solving quadratic equations, it doesn't really matter which way you use. Yeah. And I don't really care which way you use either. Yeah. Yeah. But it's good to know a lot of different ways to do it because then you can pick and choose the ones that work the best, right? So obviously this one works best when you're doing the square root property, basically. And in fact, I can say anytime that b is equal to 0, right? So you have ax squared plus bx plus c, right? Anytime your b is 0, square root property is probably the way to go. Yeah. Fair enough. Okay, so now let's try another problem here. Okay, this time we have a 9x squared plus 25 is equal to 0. Okay, yeah. So I think I'll start off this way, subtracting 25 on both sides. Yeah, doesn't really matter, right? So let's do that. 9x squared plus 25 minus 25 is equal to 0 minus 25, right? So then we're going to get a 9x squared is equal to negative 25, right? Now I'll divide both sides by 9, right? So I get negative 25 over 9, right? And so we're going to get x squared is equal to, uh, sorry, I divided by 9. So we get negative 25 over 9. Okay. All right, so now we're ready to use our square root property, right? So by SRP, right, we get that x is equal to, well, we got to take the square root of this thing, right? So the square root of 25 over 9, right? You know what? I'll write it out first and then I'll simplify it. Let's do that. I don't want to lose anybody here. So, oops, I lost my negative sign. Okay. Oh, goodness. All right, let's try this again. Negative 25 over 9. The square root of negative 25 over 9, or x is equal to the negative square root of negative 25 over 9. All right? Yeah. Any questions on that so far? You might be tempted to try and cancel off these negative signs, but you can't. Yeah. Yeah, this isn't a negative of a negative number, okay? This negative sign right here is inside the radical. Yeah, you can't just pull things out of a radical, okay? Fair enough. So, not without taking the square root of it anyway. Okay. So, what can we do here? Well, we can simplify this still, right? This is really just the same thing as the square root of negative 1 times 25 over 9, right? And this is really the same thing as x equals negative the square root of negative 1 times 25 over 9. Okay. So we have products and quotients in there inside the radical. Okay. Now let's recall that square roots distribute over products and quotients, right? So this is the same thing as x is equal to the square root of negative 1, right? Times the square root of 25 divided by the square root of 9. Okay. Same thing here. X is equal to negative square root of negative 1, right? Times the square root of 25 over the square root of 9. And so we can simplify, right? Square root of 25 is just 5, right? Square root of 9 is just 3, so we got 5/3. Square root of negative 1 is just I, okay? Same thing here, right? Except now we have a negative sign, so we're going to get a negative 5/3 I. All right, so our solution set to part B here, we only have complex solutions. Okay. Any questions on that? Any questions on that at all? All right. So then now let's do part C. One more example of this, right? Here we're going to have x minus 2 quantity squared is equal to 6. Okay, fair enough. Which looks a little bit more complicated. Make sure to just pull my microphone out here. Yeah, it looks a little bit more complicated than what we had been doing, right? We just had x squareds before. Now we have this x minus 2, that whole quantity is being squared. But let's remember that the square root property, it says that u squared equals d, right? How to solve that. So this is my u, basically. U is just equal to x minus 2, right? So this is the same thing as saying u squared equals 6. So by square root property, oops, SRP. So by square root property, either u is equal to square root of 6 or u is equal to negative square root of 6. Okay? Now, we're to recall that my u is x minus 2, right? So this says that x minus 2 is equal to square root of 6, or x minus 2 is equal to negative square root of 6. Yeah. So to solve for x, I'm just going to add 2 to both sides of the equation, right? So we get x minus 2 plus 2 is equal to, I'll write it as 2 plus the square root of 6, or x minus 2 plus 2 is equal to 2 minus the square root of 6. I simplify, and I get x is equal to 2 plus the square root of 6, or x is equal to 2 minus the square root of 6, right? Any questions on it? Okay, so now that we have that, right? Now that we have that, my solution set is 2 minus the square root of 6, 2 plus the square root of 6. Okay. Questions? Any questions on it? Okay. Now, here comes a pretty important property. Pretty important. It's called completing the square. Okay. And before anybody asks, yeah, there will be problems specifically on completing the square on the exam. Yeah. Yeah, this is definitely something I want you to be able to do because it carries over into things that you need for Calculus 2, for those of you who are going into Calculus 2. And I'm going to teach everybody as if they are. Okay. So, completing the square. All right. So, here's basically how it works. You have a quadratic equation. Ax squared plus bx plus c is equal to 0, right? Okay. Now, contrary to the way that you usually solve these quadratic equations, my first step here is going to be to subtract c on both sides of the equation. Okay, so what is that going to look like when I subtract c? Well, I'm just going to have ax squared plus bx equals negative c when I do that, right? Yeah. Any questions on that so far? Okay, now, next step. Divide by a on both sides. Okay, that's just to get your basically your leading coefficient to be 1, because it's just easier to do things if your leading coefficient's 1. Okay, so if I divide by a on both sides, then I'm going to get x squared plus b over a times x is equal to negative c over a. Agreed? Don't forget to distribute your division distributes, right? Everybody good so far? Right? Because I'm trying to present this in steps that are easy to follow, right? So is everybody okay so far? Yeah. All right. This is the most complicated step right here that comes next, okay? We're going to add b divided by 2a quantity squared to both sides. Okay. Seems kind of a weird thing to do, but that's what we're doing. Okay, b divided by 2a, quantity squared. Now remember, you already know a, b, and c because it's given to you in the problem, right? We give you the quadratic equation. So you know your value of a, you know your value of b, you know your value of c from the start of the problem. Okay, so we could plug in b, we could plug in a over here. We could compute what that is, right? And now we could take that quantity and square it. Okay, so we're just adding a number to both sides that we know how to compute. Okay. Yeah. So what does this look like? We get x squared plus b over ax plus b over 2a squared equals b over 2a squared minus c over a. Yeah. Yeah. Now that right-hand side, I'll grant you that looks really complicated, but it's just a number, right? You plug in your a and b and your c, right? And you get a number, right? You might be wondering, well, what if a is 0, right? We'd be dividing by 0. But remember, we're talking about a quadratic equation, so a is definitely not 0, right? That's part of the definition of a quadratic equation, so don't need to worry about that. Okay. All right, step 4. Factor the left-hand side. Now you might say, oh, well, that sounds really complicated, but with all that we've done over here, this always factors as x plus b over 2a, quantity squared. Okay. Yeah, so we factor the left-hand side there. Yeah. It always factors as that though, right? If we've done our completing the square steps correct so far, then the left-hand side will always factor like this. Yeah. So we basically have some quantity squared is equal to some number over here, right? After we plug in a, b, and c, right? This is just some quantity being squared is equal to some number. Now, use square root property to solve for x. All right. Since we have a quantity squared is equal to a number, square root property applies. Yeah. All right. Any questions on that? Any questions on that? Can everybody read those steps? Okay. Yeah. I'm going to do my example right over here beside it so we can see the steps in action, basically. Right. Okay. Here's what we have. X squared minus 6x plus 4 is equal to 0. Okay. All right. So step 1 is I'm going to subtract c on both sides of the equation, right? So step 1, we're going to have x squared minus 6x plus 4, and I'm going to subtract 4 on both sides, right? So 0 minus 4. So then we're going to wind up with x squared minus 6x is equal to negative 4. Okay. So that's my step 1. Any questions on that? Okay. All right. Now my step 2 is to divide by a on both sides, but my a is already 1, right? So my step 2 is done since a is 1. Yeah. Is everybody okay with that? Right. So you know what your A value is, what your B value is, and what your C value is. Yeah. Any questions on what that is? All right. Then we'll go on to step 3, right? Which again is the most complicated step here, right? But keep in mind, the coefficient on X right here, that's already B over A, right? So if I take half of that, then that would be B over 2A. Yeah. So B over 2A, in this case, will just be half of negative 6. Yeah, half of negative 6. So that would be negative 6 over 2, which is negative 3. Yeah, fair enough. So that's my b over 2a right there. Yeah, so I've already computed what that is, right? Now, we're going to add that to both sides of the equation. So I'm going to have x squared minus 6x plus b over 2a, quantity squared, to both sides. All right, and what's my other side here? Negative 4. Okay. Any questions on that so far? Notice that I did use parentheses there, right? Around my -3, right? Yeah, because the entire quantity is getting squared there, right? B over 2a, the entire thing is getting squared, including the negative sign, right? Yeah, so you'll always get a positive number from this, right? Okay. All right, so let's look at my left-hand side now, right? So this is going to be x squared minus 6x plus 9 is equal to, well, this is just a 9 minus a 4, which is 5, right? So that's what we have now after step 3 is done. Any questions on that? Okay. All right. Now we factor the left-hand side, right? And now remember, it always factors as x plus b over 2a, quantity squared, right? So this left-hand side, we don't even need to think about it. This is just going to be x plus -3, quantity squared, right? And that's going to be equal to 5. Yeah. And you can check it, make sure it works. It does. Yeah. And then now, of course, I'm going to write this as x minus 3 squared equals 5, right? Just looks nicer. All right. Now let's apply square root property, not SQ, SRP, right? Apply SRP to say that x minus 3 is equal to square root of 5, or x minus 3 is equal to negative square root of 5, right? And just taking square roots on both sides, right? Okay. Now I'll add 3 to both sides of the equation to get x by itself. All right, so this is going to be a 3 plus the square root of 5. Or we'll have x minus 3 plus 3 is equal to 3 minus the square root of 5. Okay. And so we're going to get that x is equal to 3 plus the square root of 5 as one solution. X is equal to 3 minus the square root of 5 as my other solution. So my solution set is 3 minus the square root of 5, 3 plus the square root of 5. Okay. Okay. Any questions on that? Any questions on that at all? Okay. Well, let's see here. Let's see what I want to do here. So we're going to go over the very last thing, really, which is the quadratic equation, a quadratic formula, right? Yeah, so solving quadratic equation using the quadratic formula. Okay. And it's great, actually, because it always works, no matter what quadratic equation you have, right? Solving quadratic equations using quadratic formula. So it's extremely powerful, right? Can be kind of difficult to use because you got to plug in a lot of numbers, right? But let's see how it works here. There's a little minor proof of it. Basically, we're starting off with a quadratic equation like this. Oops, that should say bx right there. Plus c is equal to 0. And then now from completing the square, right? We know that, and I'm going to scroll up just a little bit here. Right, we know that that's basically equivalent to this. After we complete the square, we get that, basically. So I'm just going to copy that back down over here. Right, ax squared plus bx plus c, that comes out to be equal to x plus b over 2a quantity squared equals b over 2a quantity squared minus c divided by a. Right? So that all comes from just the completing the square. It's all the same steps we did before. Okay. And now I'm going to clean up the right-hand side just a little bit. Okay, just a little bit. So we have x plus b over 2a quantity squared is going to be equal to, well, this is a b squared over 4a squared if we were to actually square that out, right? B squared over 2 squared a squared, right? Minus c over a. And then now I can get a common denominator. Oh, sorry. Let me try to write a little bit bigger, a little bit neater here. So my left-hand side still hasn't changed here. My right-hand side here, right? We're going to get a common denominator. So we want this to be a 4a squared on the bottom over here, which means that we need to multiply this denominator by 4a. And I thought I changed pens there. Hold on one second. There we go. So we need to multiply this denominator by 4a, which means we also need to multiply the numerator by 4a, right? Yeah. And so we're going to get that this is b squared over 4a squared minus 4ac over 4a squared, right? So now we have that common denominator there, right? All right, so then I have x plus b over 2a squared is equal to, well, this is all over 4a squared here. So we have a b squared minus 4ac, all divided by 4a squared, right? Now we apply the square root property. Square root property, right? Which tells us that x plus b over 2a, if we take the square root on both sides, right, will be equal to either plus or minus the square root of b squared minus 4ac over 4a squared. Okay. Now, I'm going to distribute the square root to the numerator and the denominator of this fraction. So we get x plus b over 2a is equal to plus or minus, well, the square root of the numerator, that's quite complicated, and we can't do anything with that. B squared minus 4ac. The square root of the denominator, though, right? Well, the square root of 4 is 2. The square root of a squared is just going to be a, right? So we have x plus b over 2a is equal to plus or minus square root of b squared minus 4ac over 2a, right? Now I'll get x by itself, so I'm going to subtract b over 2a on both sides, right? So I'm going to take my x plus b over 2a. I'm going to subtract b over 2a. That's going to be equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. All right. On the left-hand side, I'm just left with x. On the right-hand side, we have a common denominator of 2a, so I can put this all over the same denominator here. And we get negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. And this is your quadratic formula. Quadratic formula. Okay. Yeah, and it always works for any quadratic equation. So, questions on that? And just in case you've never seen a proof of the quadratic formula before, it follows from completing the square. And then just, putting things carefully algebraically. That's all it is. Okay. All right. So let's try it out, right? Like we don't need to prove the quadratic equation, right? Yeah, let's just see if we can use it. So we have, let's say, a 9x squared minus a 6x minus a 4 equals 0. Okay. All right. And whenever I'm using the quadratic formula, I like to first just label what my A is, what my B is, and what my C is, just for my own sake, okay? So A is 9, B is negative 6, C is negative 4. Okay. Okay. So now that I have that, my A is 9, my B is negative 6, my C is negative 4, I can immediately say, by quadratic formula, X is equal to, well, you can just write down the formula again, but it's right up here, right? So it's negative b, so it's negative 6, plus or minus the square root of, it's b squared, so we have a negative 6 squared, minus 4 times a times c, all divided by 2 times a. right? Pause here for a second. Any questions on how I plugged in those numbers? Anything at all? Any questions on that? Okay, so now let's just simplify, right? So we have x is equal to, well, let's see. Up top, negative 6 is, of course, just 6. We get plus or minus the square root of negative 6 quantity squared is 36. Again, don't forget to use parentheses. You're squaring the negative as well, right? Yeah. And then we have minus 4ac, right? So we're going to have 4 times 9 is also 36, right? 36 times negative 4, so this is going to become positive, right? So let's see, that is 144, right? All over 18. Okay, notice how this became a plus? We have minus a negative number, right? Yeah, very important. Just a little bit. Yeah, how about that? Yeah, no problem. Okay, so I wonder if I could put this bar over here on the left. Is that possible? No, I hate OneNote. Okay, so then now, right, let's see if we can simplify this a little bit. We got 6 plus or minus the square root of, well, we have 144 plus 36, which is like what, 180? Yeah, all over 18. All right, now we got to simplify the square root of 180. All right, well, let's do it. So we have 180. Well, that's definitely 60 times 3, right? Fair enough. And then 60, well, that's definitely 20 times 3. Yeah. And then 20, well, that's definitely 4 times 5. Right? So we have a perfect square here, and we have a perfect square here, right? So I'm going to write this thing as x is equal to 6 plus or minus the square root of 180 can be written as 2 squared times 3 squared times 5, right? All divided by 18. Okay. So then now, 2 squared, when I take the square root of that, I get 2. 3 squared, when I take the square root of that, I get 3. So I'm going to get 2 times 3 is 6. All right. 5 is not a perfect square, so it's got to stay underneath the radical there. All over 18. Okay. Now you might be tempted to simplify the 6 and the 18 here. Just be very careful when you do that. You can only cancel things in the numerator with things in the denominator if you factor them out first, right? Yeah. So I can factor a 6 out of the numerator, no problem. But then I'll be left with 1 plus the square root of 5, right? If I factor that 6 out. Downstairs, I can factor a 6 out of this 18. No problem. That's 6 times 3. So now my 6's cancel off. Oh, I lost my plus or minus there. There we go. So I get that x is equal to 1 plus or minus the square root of 5 divided by 3. Okay. 1 plus or minus the square root of 5 divided by 3. So then I get 1 plus the square root of 5 over 3 and 1 minus the square root of 5 over 3 as my answers. Okay. All right. Any questions on that? Any questions on that? Oh, by the way, when studying for the exam, it's probably a good idea to go back through the examples and see how I showed the work, right? Because this exam is probably going to be free response questions, written response questions, right? Where you have to show your work for every problem. Yeah, and so you kind of want to show your work the same way I do. At the very top over there, yeah, that is a great question, right? Because there are a lot of numbers running around. So you have to remember that the general form, the standard form for a quadratic equation is ax squared plus bx plus c is equal to 0. Okay, and then you kind of compare coefficients, right? So your coefficient on x squared, that's your a. So that's how I got a is 9. Your coefficient on x, that's your b. And so that's -6. And then your coefficient here, or just your constant term, right? That's C. So it's -4. Okay. So then now that I have labeled these as A equals 9, B equals -6, C equals -4, now I plug it into the formula. It's negative B, so we get -6, plus or minus. All right, there we go. Plus or minus the square root of B squared minus 4. All right. Well, that's got okay. Minus 4 times A times C, right? All okay. I don't know how often it's going to be doing that. All over 2A. Fair enough. Yeah. I don't know if this is a problem with OneNote or the projector or the monitor, but it does this in several classrooms. Yeah. Huh. Okay. Hopefully it doesn't do that again while we're recording here. So now that I have that, right, let's do one more example of quadratic formula, and then we'll finish it up with one final thing after that. Okay. So we have a 3x squared minus a 2x plus a 4 is equal to 0. And again, I'll label that my A is 3, my B is -2, and my C is +4, right? So I can say by, but I call this a Pythagorean theorem, but by the quadratic formula, right? What can we say? We know immediately that x is equal to negative b, so that's -2, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, fair enough. And now we simplify, right? Because I mean, we have the solution right here. So the rest of it is really just simplifying. It's just very careful arithmetic, right? Is the rest of this problem. So let's see what we have here. So -2 is, of course, +2. We have plus or minus the square root of, well, -2 squared is 4, right? Then we have minus a 4 times 3 is 12 times 4 is 48, right? All over 2 times 3 is 6. Again, feel free to use a calculator to help you simplify some of these things, right? So, like, for example, inside the radical over here, right? If I have -2, remember this is your negative sign. Don't use a minus sign. You have to use a negative sign. I don't know why it's different. So we have -2 squared, right? Minus 4 times a times c, right? Comes out to be -44. So this whole thing right here comes out to be -44, which is what we'll get when we do 4 minus 48, right? So we have x is equal to 2 plus or minus the square root of -44 over 6. Okay. All right, so we know we're going to get an imaginary number here, right? But we still need to simplify square root of 44 also, right? So 44 is the same thing as 4 times 11, right? And 4 is a perfect square, so that's great. So then we're going to get that x is equal to 2 plus or minus the square root of -1 times 2 squared times 11 all over 6. And so we're going to be able to simplify this quite nicely. This is going to be 2 plus or minus, well, square root of 2 squared will just be 2, right? And then we're going to get square root of 11. And then square root of -1 is I. So 2 square root of 11 times I, all over 6. Okay. Yeah. Usually I put my real numbers first before I put my I, right? Yeah. So that's why I have it written this way. Yeah. Usually I'll put my whole number values first before my radical, so that's why I have it written in this order. Okay. All right, now I can factor a 2 out of the numerator and the denominator. So I get 1 plus or minus square root of 11i. All right. And then I can factor a 2 out of the denominator too. I think it'll catch up in just a second. Or not. Maybe it'll just ignore my inputs. There we go. Wow, this computer sounds like it's really struggling. I think it might be the computer that's the problem, actually. Okay. So then now my 2's cancel off, and I get x is equal to 1 plus or minus the square root of 11I divided by 3. Okay. Okay, so my solution set is 1 plus the square root of 11I over 3, and 1 minus the square root of 11I over 3. Okay. Any questions on that? Yes. Oh, so I'm taking the square root of a negative number. So yeah, you can remember that you're going to get an imaginary number when you do that. But I actually wrote it out as -1 times 2 squared times 11. So when I take the square root of -1, that's where the I comes from, right? Yeah, when I distribute that square root. Yeah, okay. Okay. Other questions? Oof. All right. So just one more thing I want to tell you about in this section, and then we can go. The discriminant. Okay. The discriminant will tell you how many solutions you have to a quadratic equation. Yeah. And it'll tell you the types of solutions, whether they're real or whether they're complex. Okay. So just quickly here, b squared minus 4ac, the part that's underneath the radical, right? That is called the discriminant. Hold on. Yeah, it's definitely one node. That's the problem. Okay. Okay. That's called the Nope. That's not how we spell it. Discriminant. Okay. Okay. Of your quadratic equation, so I'll just say of ax squared plus bx plus c equals 0. And so here are some rules for us that establish when we're going to have a certain type of solution, okay? So if b squared minus 4ac is greater than 0, then the quadratic equation will have two real solutions. And I mean two distinct real solutions, right? Two distinct real solutions there. Right, so I'll write distinct right here. Okay. On the other hand, if b squared minus 4ac is exactly 0, then the equation will have one repeated solution. Okay, so I'll just have that one repeated solution then. The only other option is, well, what happens if b squared minus 4ac is less than 0? Well, if that happens, then the equation has two complex solutions. So we'll have, and in fact, they're going to be complex conjugate solutions, right? So I'm going to call this a complex conjugate pair of solutions, right? Like in the last example that we did, right? The last example we did, we had that those were complex conjugates of each other. Okay. Yeah. Okay, so those are our rules there, right? If we could compute our discriminant, right, it's either going to be positive, 0, or negative, right? And so that leads to our three possibilities. Okay. Yeah. Now, quick example for part A here, right? 3x squared plus 4x minus 5 equals 0, right? And so we want to know how many solutions there are, what types of solutions there are, right? How many and what types of solutions, right? So we're going to compute b squared minus 4ac, right? So that's going to be b squared is 16 minus 4 times 3 times -5. Well, this is, of course, greater than 0 because it's a positive number plus a positive number, right? So two real solutions. Okay, two real solutions. For part B here, what if we had 9x squared minus 6x plus 1 is equal to 0? Well, let's see. We have b squared is 36 minus 4 times a times c. Well, that's going to give us exactly 0, right? So we have one repeated real solution. Okay, one repeated real solution there. Okay, and we could find it if we want. It's like x equals 1/3 or something. Yeah. For part C, right? If we have 3x squared minus 8x plus 7 is equal to 0, right? Well, then b squared minus 4ac. So that's b squared will be positive 64, not negative 64. It's positive 64, right? Minus 4 times a times c, right? Well, 4 times 3 times 7 is like 68. Yeah, is that right? Well, 4 times 3 is 12 times 7. No, so it's even more than that. It's 84. So 64 minus 84 is definitely less than 0. Okay. So then we're going to have a complex conjugate pair. Complex conjugate pair of solutions. All right. Well, you can take my word for it. I was going to write complex conjugate pair of solutions there, and then that would be the end of class. So if there was a point where this should like stop working, it would be right now anyway. So, all right, I'll see you guys on Tuesday where we're going to have our exam review, right? Our exam's going to be a week from today. Okay. I'll post some notes about what the exam's going to look like online sometime this weekend. Like look for it on Saturday maybe. Okay.